When studying derivatives, so far we've used the power rule, the sum and difference rule, the product rule, the quotient rule, and now we have the chain rule. At the end of this lesson, you'll be able to use the chain rule to find the derivative of a function. Right, to get us started with using the chain rule, I just want to show you the type of problem that you would use the chain rule on by using an example. You'll notice in this first one, it asks us to find f of g of x. So if you recall from previous chapters, to find f of g of x, we're actually going to take g and we'll plug it in for the x on our f function. So we will end up getting 3x plus 1 squared. Okay, now notice over to the right, it asks me to find the derivative of f of g of x. Well, in order to take the derivative, I'm first going to need to multiply that out. I know that 3x plus 1 squared is really 3x plus 1 times 3x plus 1. And if I multiply that out, I'll get 9x squared plus 3x plus 3x plus 1. And then if I go one step farther, I'll get 9x squared plus 6x plus 1. Notice so far I've just simplified. I haven't taken the derivative. So now if I take the derivative of f of g of x, I'm going to take the derivative of that. To do that, we'll just use our power rule. We'll end up getting 18x plus 6. And I could go one step farther. Since I noticed 6 will divide evenly into both parts, if I factored out a 6, I'd be left with 3x plus 1. So notice really that wasn't too bad at all. But what if I had a problem that looked like this, 3x plus 1 raised to the 5th power? Then I'd either have to multiply that out 5 times, or I could use Pascal's triangle, but the workload would become quite a bit more when I'm trying to take the derivative of that. So when I have something in parentheses, that would be a perfect candidate for actually me using the chain rule instead of multiplying it all out. Okay, the chain rule basically, it kind of looks crazy, but it's basically saying if you have the derivative of a composite function, you've got something in parentheses and then we've got something happening on the outside, we're basically going to be taking the derivative of the outer function times the derivative multiplied by the derivative of the inner function. And I'm just going to read what's on this slide. If you are using the power rule on more than just x, when you are done using the power rule, you must multiply by the derivative of the chunk that is more than just x. And what we're going to be doing is actually doing something that's called a u substitution to help us out a little bit. Okay, you'll notice I do have some notes on this u substitution. We'll be referring to those, but mostly I'm going to try to show you an example to help you understand. All right, I've got this piece of chocolate, and you'll notice that it's got a wrapper, and then inside there is unbelievably delicious chocolate. So what you can think of is think of the wrapper as being the parentheses. So what we're basically going to be doing is first of all taking the derivative of the wrapper. And so then when I'm done, after I've taken the derivative of the wrapper, I still want to get the chocolate on the inside, the unbelievably good chocolate. And what we're going to be doing is letting the inside of the chocolate be represented by the letter U. And so before I'm done, we're going to take the derivative of the outer stuff, the wrapper, but I'm not done until I've multiplied by the derivative of the chocolate. So that's basically what a U substitution does. And why would I use this approach? It just makes the problem less bulky to work with. So I'm going to go back to my previous example. Now we're going to treat it a little bit differently, and we're going to kind of do the wrapper chocolate type thing with the substitution. So what we're going to be doing is I noticed that there are parentheses. So what I'm going to do is be taking the inside of the parentheses. That's my chocolate, and it's unbelievably good chocolate, so we're going to represent that with the letter U. Okay, so what we're going to do now is if I rewrote that, that now really is just the function u squared. So we've just simplified it a little bit. Now when I go to take the derivative, and again we're taking the derivative of that whole entire thing here, taking the derivative of u squared is just simply 2u. But now don't forget, we can't forget the chocolate on the inside. We're not done until we've multiplied by the derivative of the chocolate, or by that u. So the derivative of the inside would be 3. And now if I just clean that up a little bit, 2 times 3 is 6u. And now I'm not quite done, because now I have to replace my u back into the problem, and it will be 6 parentheses 3x plus 1. And you'll notice when I did that, I got exactly what I got the other time. So hopefully now you're a little bit familiar with using the chain rule to find the derivative of a function.